Close your eyes for a second and imagine this. You're driving down a busy city street. Traffic lights are changing, pedestrians are crossing, motorcycles are weaving between cars, and an ambulance siren suddenly blares from behind. Now imagine your car, not just you, understanding all of this. Imagine it recognizing the red light ahead, predicting the pedestrian's movement, and even moving out of the way to give space to the ambulance. Sounds like science fiction, right? But in reality, it's already happening thanks to something called computer vision. In today's video, we're going to explore how cars see the world, how computer vision works, what challenges it faces, and how this technology is shaping the future of driving. Trust me, you'll never look at cars the same way again. Welcome back to the channel. If you're new here, we break down cutting-edge technologies and explain how they're transforming our lives. Today's topic is all about computer vision in cars, the technology that acts like the eyes of autonomous vehicles and advanced driver assistance systems. You see, human driving depends on vision. We look at the road, we spot obstacles, we read signs, and we react. Cars with computer vision do the same thing, except they use cameras, sensors, and artificial intelligence. And here's the kicker. Unlike humans, cars don't blink, don't get distracted, and can process information faster than we ever could. So how exactly does a car see the world? Instead of human eyes, it uses a combination of sensors and cameras. Let's break them down. Cameras. These act like high-resolution eyes. They can be placed at the front, back, and sides of the car. Some vehicles even have 360-degree camera setups. Cameras are excellent for capturing lane markings, signs, and traffic lights. LiDAR, light detection and ranging. Imagine a spinning laser constantly scanning the environment, creating a detailed 3D map of everything around the car. LiDAR is like giving the car X-ray vision of the surroundings. Radar. While LiDAR and cameras give detail, radar is fantastic at measuring distance and speed, especially in tough conditions like fog, rain, or darkness. Ultrasonic sensors. These are short-range sensors used for tasks like parking. They can detect curbs, walls, or other cars very close to the vehicle. Different companies use these tools differently. For example, Tesla prefers cameras and neural networks to interpret the road. Waymo, on the other hand, invests heavily in LiDAR for precise mapping. The combination of these sensors gives the car a layered view, like human vision plus superpowers. Now that we know what the car uses to see, let's dive into how it processes this information. This is what's called the computer vision pipeline. Think of it like the brain interpreting what the eyes are seeing. Step 1. Image capture. The car constantly takes in raw visual data through cameras and sensors. Step 2. Pre-processing. This raw data isn't always perfect. The car's system cleans it up, removing noise, correcting for lighting changes, and enhancing contrast. For example, if it's a bright sunny day or a dark rainy night, the system adjusts so it can still see clearly. Step 3. Object detection. Here's where the magic starts. The AI identifies objects in the scene. Other cars, lane markings, pedestrians, traffic lights, bicycles, even animals. Step 4. Object classification. The system doesn't just say, "There's something there." It knows what that something is. Is it a truck, a stop sign, a human, or maybe just a plastic bag blowing in the wind? Classification matters because the car reacts differently depending on what the object is. Step 5. Object tracking. Once objects are identified, the car doesn't lose sight of them. It tracks their movement in real time, predicting whether a pedestrian will cross or if another car is about to merge into your lane. Step 6. Decision-making. This is the final and most critical step. The car decides what action to take: slow down, brake, steer, or maintain course. And here's the amazing part. This entire process happens in milliseconds, faster than the blink of an eye. That's why computer vision is such a game changer. So, what does all of this mean for everyday driving? Let's look at some of the ways computer vision is already being used. Lane detection and lane keeping assist. Ever notice your car gently steering you back into the lane if you drift? That's computer vision at work, reading lane markings and keeping you safe. Traffic sign recognition cars can now read speed limits and stop signs, alerting the driver or even adjusting the speed automatically. Pedestrian detection. This might be the most important one. Cars equipped with computer vision can detect pedestrians crossing, even at night, and automatically apply brakes if necessary. Collision avoidance systems. By predicting the movement of nearby vehicles, cars can prevent accidents before they happen. Parking assist and 360-degree views. Whether it's parallel parking or avoiding obstacles, computer vision makes it possible for cars to handle parking by themselves. Driver monitoring. Some cars even use inward-facing cameras to check if the driver is drowsy or distracted, sending alerts to prevent accidents. All of these features are just the beginning. They represent the early stages of autonomous driving. Let's take a look at some companies leading the way with computer vision, Tesla Autopilot, and full self-driving. Tesla cars rely heavily on cameras and neural networks. The system can drive on highways, change lanes, park, and even stop for pedestrians. Waymo. A pioneer in self-driving cars, Waymo uses LiDAR combined with AI to operate vehicles without human drivers in certain cities, Mercedes-Benz and BMW. Their luxury cars now come with features like adaptive cruise control, lane assist, and automated parking, all powered by computer vision. Nissan Pro Pilot Assist. A semi-autonomous system designed for highways, combining camera vision with radar to keep the car centered and at a safe distance. These examples show that computer vision isn't just in labs. It's already on the streets, shaping the way we drive. Of course, computer vision is not perfect. Let's talk about some of the challenges it faces. Weather conditions. Heavy rain, snow, or fog can blur cameras and block LiDAR signals. Humans struggle in these conditions, and so do cars. Low-light environments. Night driving is tough. While infrared helps, it's still challenging to get perfect visibility. Processing power. Cars generate terabytes of data daily. Processing this in real time requires extremely powerful onboard computers. Edge cases. What happens if there's a fallen tree on the road or a traffic officer waving cars through a red light? These unusual scenarios are difficult for AI to interpret. Ethical concerns. Here's the tricky part. What if a collision is unavoidable? Should the car prioritize the passenger's safety or the pedestrians? These are deep ethical questions still being debated. Despite these challenges, the progress is undeniable. Engineers are working day and night to make these systems smarter and more reliable. So, what's next for computer vision in vehicles? Smarter AI models. Future cars will recognize even rare and complex situations. Integration with V2X, vehicle to everything. Communication. Imagine your car talking to traffic lights, other cars, and even road infrastructure to make better decisions. Full autonomy. Eventually, we may reach a stage where human drivers aren't needed at all. Cars will handle everything, from highways to complex city driving, sustainability, and efficiency. Smarter vision systems will also help reduce traffic jams and improve fuel efficiency by optimizing driving patterns. It's clear that computer vision is not just a feature. It's the foundation of the future of mobility. To wrap it all up, computer vision is like giving eyes and brains to cars. It allows them to see, understand, and react to the world around them. From lane keeping to pedestrian detection, from collision avoidance to full self-driving, computer vision is transforming vehicles into intelligent machines that can make roads safer and travel more efficient. And the best part? This is just the beginning. The cars of tomorrow will be smarter, safer, and more connected than we can even imagine today. If you found this video insightful, do me a favor. Hit the like button, share it with your friends, and subscribe for more deep dives into the technologies shaping our future. Thanks for watching.